Hello, welcome everybody, this is Mr. Navarrete, and today I'll be going over the equilibrium constant homework number 2. So, let's get started. For number 1, it says write the equilibrium constant expression for the reaction between oxygen into ozone. Our equilibrium constant expression is a ratio between our products and our reactants. So let's do that. I'm going to create my ratio. On the top, I'm going to put my products, I'm going to put my concentration of ozone, and I'm going to put squared. I'm going to put that square because I have a coefficient of 2 in my balanced chemical equation. And then on the bottom, I'm going to put my reactants, my concentration of O2, and I can't forget my power of 3 for my coefficient of 3 in my balanced chemical equation. Now we're going to write the equilibrium constant expression for the reaction between hydrochloric acid and water to create hydronium ions and chlorine ions. So again, my equilibrium constant is a ratio between my products, so in this case the concentration of H3O plus and Cl minus, that's going to be divided by the concentration of my reactants. In this case, I'm only going to put hydrochloric acid because my concentration of water is not going to change. The concentration of water will always stay the same. Now we're going to look at the reaction between zinc oxide, carbon dioxide to create zinc carbonate. My constant expression is going to be K. I'm going to create a ratio, and on top I'm going to put my products. In this case, it's going to be a solid, so I'm not going to include it because my concentration for it is not going to change. It'll stay constant. On my reactants, I'm only going to include carbon dioxide gas because that's the only one whose concentration will change. My solids, their concentration won't change, so I won't include them in my rate expression. Now we're going to write my equilibrium constant expression for the reaction between water, solid carbon into carbon monoxide and hydrogen gas. Again, my equilibrium constant is just going to be the ratio between my products and my reactants. I'm not going to include any solids since their concentrations won't change. Now we're going to look at the decomposition reaction between calcium sulfate into calcium ions and sulfate ions. My constant is, again, it's a ratio between my products and my reactants. Because my reactant is a solid, concentration is not going to change, but it's still a ratio, so I still have to include that one there. I'm just going to continue practicing writing our ratios between our products and our reactants. Again, don't include solids since their concentrations won't change. And also don't forget to include your coefficients as their powers. We're going to continue with the same idea. Constant expression is just the ratio between our products and our reactants. And again, I'm not including my solid since its concentration will not change. Same idea with number 9. We're going to practice writing our ratios between our products. In this case, we're not including our liquids since our concentration won't change, and our reactants. Make sure to include the 2 for your coefficients. Don't forget them, they are important. And last one for the section, same idea, writing our ratios between our products and our reactants. We're not going to include our solids. We're only looking at the ones whose concentrations can change. Let's move on to part 2. For number 1 and part 2, we're asked to verify the equilibrium constant expression for the following reaction. First thing I'm going to do is write my equilibrium constant expression. So, again, that's just my ratio between my products and my reactants. Don't forget to include your coefficients as powers in your expression, because now that we're doing our calculations, missing them will give us the wrong rate. So now that we have our expression, we can use our table to plug in our values. For my first trial, I'm going to look at my data for number 1. And I'm just going to plug in my concentrations. Once I have this, I can plug that into my calculator and get an equilibrium constant of 0.010 with sig figs, of course. I'm going to do the same thing for the second trials. Just plugging in my concentrations and again into my calculator to get my next constant. Again, I get 0.010 with sig figs. And for my last one, just going to plug in my concentrations and plugging them into my calculator to get an equilibrium constant of 0.010. For 2, we're given the reaction of oxygen gas into ozone. I'm just going to take the equilibrium expression that I made earlier in one of the homework problems. So I know that my equilibrium is going to be my concentration of ozone, my products, divided by my concentration of oxygen gas, my reactants, and making sure to include my coefficients as my powers. With that and my data table, I can plug in and find my equilibrium constants. For trial 1, I can just take my data, plug it in, and put it into my calculator and get an equilibrium constant of 0.751. I can continue doing this with the other trials. Number 2, I'm going to plug in my data, then into my calculator to get 0.751, with sig figs, of course. And lastly, for my third trial, I'm going to get my equilibrium constant to be, with sig figs, 0.747. 3, now we have bromine gas into its bromine ions. So I'm just going to write my equilibrium constant expression of my products divided by my coefficients. And again, making sure to include my coefficients as powers. And now with my table, I can find my equilibrium constant. For my first trial, I'm going to get my concentration of my products squared divided by my concentration of my reactants, plug that into my calculator, and get 0.0250 with sig figs. Same thing for my second trial, and I get an equilibrium constant of 0.0251 with sig figs. And for number 3, I'm going to plug in my data, and my calculator tells me that I get an equilibrium constant of 0.0250 with sig figs. Lastly, for the decomposition reaction between nitroso bromide into nitric oxide and bromine gas, my equilibrium constant expression is just my products divided by my reactants, making sure to include my powers for my coefficients. And now with my data table, I can just simply plug in. For my first trial, I'm going to get my concentration of nitric oxide squared times the concentration of bromine gas, all of that divided by my concentration of nitroso bromide squared. And putting that into my calculator, I get an equilibrium constant of 25 with sig figs. For my second trial, I'm going to do the same thing and get an equilibrium constant of 25. And for my third one, I'm going to, again, just plug in my data for the third trial, then transfer it into my calculator and get an equilibrium constant of 25. And that's it. If you have any questions, don't forget to message myself or Mr. Morgan on Schoology. Other than that, stay safe, and I'll catch y'all next time.